So hi techies, welcome back to the channel, and in today's video we are going to understand how RAG or Retrieval Augmented Generation works from scratch. So if you have ever wondered how ChatGPT can answer questions from your own PDFs, company's document or private knowledge base without retraining the model, then RAG is the technology behind it. Instead of memorizing all the information inside the LLM, RAG retrieves the relevant information first and then give it to the LLM before generating the answer. So before understanding the complete workflow using this architecture, let us discuss why we use RAG instead of not LLM. So basically the problem which we faced with LLM was for training an LLM with the data, it was basically being costly and nobody wanted to share their private data. Why would say you want like some data is private, why you want it to do it publicly, because when you will train with LLM it will become public and costly will be there. So like not fit for 50-100, but if you like do with a lot of data, then LLM would not be suitable for that. That's why RAG come into the frame. And trust me guys, with this diagram, with this only diagram, I will be explaining you whole RAG architecture from start to the end. You just have to pay your attention in the video and be with me. If you are not getting anything, just rewatch it. Simple. You could have like your mind have been diverted to some place, that why you are not able to understand. Just rewatch the video and RAG, next time you will explain RAG by your own terms without seeing anything. Trust me guys. So let's understand the complete workflow using this architecture which you can see on your screen. Step 1 is your source document. I would write by step 1. Step by step I would write. Let's first erase it and now my step 1 is okay. Step 1. What is step 1? Source document. So everything starts with our documents. These documents can be anything. What it can be PDF file, it can be Word document, it can be Excel file. It doesn't matter which type of file it is. The source document can be anything. Research paper, company policies, medical reports, books, websites. The source document can be anything. It just want data inside it. It can be of any format. Except this format, there are also many, but right now I am remembering these. So, and these are more than sufficient. Mostly we do with PDFs, Word document and Excel file. These are also very much people use, but these are the main which we generally use. So, these documents contain the knowledge we want our chatbot to answer from. So what I say, suppose I will take a PDF, I will suppose I will take an example here. I will take an example. I have a PDF about machine learning. Okay, I have a PDF, or it can be a book of machine learning or a PDF of machine learning. I want my chatbot to answer question only from that PDF. So basically, what I want, this is a chatbot, this is a machine learning book. I want to train that chatbot with this book and I want it to give me answer which I like. This is me. I will give it a question and I want that this chatbot should answer me from this book and return me the answer. This is the whole thing I want. Okay. So first we need to convert this document into something that AI understand. Does AI or machine understand words, images? No, not at all. It just understand numbers. So with I've given you the idea of our next step. Yes, it is embedding models. And this is here the step from where RAG starts. Okay. Very interesting, and you can say embedding model, embedding is the heart of RAG. Understand it carefully. Okay. So this is where the machine model comes, embedding model comes in. And embedding models converts text into numbers. Okay. I will explain you in simple terms. Don't worry about that. Step 2. See, I can't explain you whole RAG in one go. I have to explain you step by step, and I will explain you in that way only. Okay, don't worry about that. So basically, what does suppose this is an embedding model. I am giving it text and it is converting it into numbers. Simple. I am feeding it text, it is converting it into numbers. Okay. But the numbers are not like 1, 2, 3, but mathematical representations that capture meaning of the sentence. Example, if I give it a sentence, dogs are loyal animals. Embeddings will become 0.23 minus 0.81 comma 0.45 and something like that. Okay. Another sentence I give it to her, my embedding model. Puppies are friendly. Now it will be giving, the embedding model will be generating something like 0.21 comma 0.79 comma 0.48 comma and so on. Can you observe something in these two vectors? Just observe it. I am giving you a second, just observe it. Yes, they both are very similar. Notice these vectors are very similar because both sentences have similar meaning. Really? Yes. Dogs are loyal animals, puppies are friendly. They both are similar sentences. That's why they are having somewhat similar vectors, not same. These words are different, the vectors would be different. Definitely they would be different, but they would be same. And this similarity will help us in later to extracting this text from the database, but don't go into that, just step by step you understand. Now, what if I write capital of France is Paris? Now, will it be similar to this? No, it would be something different. And so on, because this has to do nothing with this or this, but the both are interconnected. That's why their vectors are similar. Okay. Now, I will explain you. See, I will explain you semantic meaning, and this is very important from the point of view of interview and understanding the embedding model. See, embedding models don't focus on exact word, they focus on meaning. Okay. For example, I write car, automobile and vehicle. So, will they produce, my question to is, will all these three will produce nearby vector? Yes or no? Just think about it, and if you have been listening to me carefully, you would have answered this in one go. The answer is yes. Though car has CAR is somewhat near to VHICLE, or automobile, this is 3 letter, this is 10 letter, suppose this is 8 letter, but the meaning of all these three are somewhat similar. So that's why their vector would be somewhat nearly same. Okay. And that's called semantic similarity. Okay. So I would write the definition over here for you. Just a second. Semantic. So embedding models don't focus on exact word, they focus on meaning. Okay, I hope you got it. Next, which step? Step 3. Embeddings. Embeddings. From source document, we move to embedding model. Now we have gone to embeddings. Okay. So after every document is converted into embeddings, now we have a vector representations. See, think of every document as a point in a huge mathematical space. Instead of storing words, we store vectors. Example, we can take 0.12, 0.45, 0.82 and so on. This is document 1. 0.74, 0.11, 0.62 and this is document 2. 0.92, 0.53, 0.31 all are stored in the form of vectors. Okay, so these are the embeddings which you can see on your screen. Next comes the step 4, which is vector database. This, and can you see one thing? Just see carefully. Vector database is the only thing which is connecting us from this user. When the user will ask question and from the source document, this is the only thing which is converted. This is common between these two. Embedding model is been there, embedding is also there, but here we have different embedding. From the source document we have embedding, here we will be having the embedding of the user query, but the vector database is common. Here also it is storing the same document and here also it is storing the from there we are retrieving the same points. Okay, so now see, one thing I forgot to tell you, whenever embeddings are being stored into vector database, it is not just the embeddings which we store. Suppose for document 1, this is the embeddings, we also store the original text like A, B, C, D and all that, like original set that. And one more thing we store, metadata. Now what is metadata? I will tell you. Suppose with the example I will explain you and you will never forget metadata in your whole life, I promise you that. Suppose you click an image of your friend. Okay, so how does that image get stored in your phone? It also takes some extra information. For example, first information it takes it of like when was the date and time when was the picture was clicked. If your location is asked, was on, it also stored the location along with it, resolution of the image, pixel of the image, who the person is, where, so that somewhat you said see that in your gallery you get memories of that place, of that particular person. What is giving you that memory? Because of metadata. Phone doesn't know that image is of your friend Rahul and all that. It is just comparing the faces, and like from the place will show you 1 year ago at a particular place like Bhubaneswar. So all the images which are stored from the location, it will from the gallery metadata has been extracted of that image, and the common places will be it makes a folder and send it to you. So these three things are stored at once in the vector database: the original text, the vector form and the metadata. Why the original? When once we will compare the vectors, We will be taking the original text to the LLM so that it can generate answer, and the metadata, like metadata will be storing the page number and all that, so that it could become for easy for LLM to include all that details. It will fetch that from page number this, it is written that this, so it will become easy for you to generate answer. Okay, now this is vector database. Now where do we store all these vectors? Yes, inside a vector database. Some of the vector database which we use is FAISS. Sorry, I can't remember its full form right now. ChromaDB, Pinecone, Wavewide, and Milvus. See, telling you answer, I've been making projects and all that using RAG. These are the mainly which we use, these two, and these are the less we use. Most is ChromaDB which we use. I've also made a project. If you see in my channel, I've also make a project on RAG, and there also I've used ChromaDB. But FAS is also very much used. So these are the some of the databases which we use. But can you, if someone has done SQL, someone watching my video has done SQL, can you just tell me the difference between an SQL database and a vector database? Okay, I will tell. Unlike SQL databases, vector database don't search keywords, don't search using keywords, they search using mathematical distance between vectors. In SQL, you have words you search using keyword, but in vector databases, you have vectors so that we can find from the mathematical differences. Okay. Now, the vector database's only job is finding the most similar vector. Okay, it doesn't generate answer, it doesn't make embeddings, it just stores. Vector database, it just stores the data. Okay, now step 5. What is step 5? Let us see now. These 4. Now step 5, user ask a question. Example, a user has trained a machine learning book inside the source document. Now it will be asking a question from it will be from the LLM, it will be asking a question, what is machine learning? A book has been trained and he's asking on a machine learning, and he's asking now question, what is machine learning? We will understand this now. A question has been asked, user ask a query. A query can be anything. I have taken a basic, you can take any query, but it is from the source document only. Okay, it is not outside from that, remember that. So my question is, let's say, what is supervised learning? Okay, what is supervised learning? Now observe one thing, the query is also passing from the same embedding model. Normally we take same embedding model, sometimes we take different also, it's not a big issue. And then the query is converted into embeddings. This is the embeddings, and this is called query embeddings. User asks a question, it passes through the embedding model, and then it is converted into embeddings. Okay, now step 6 which we have is similarity search. This similarity search, and trust me guys, this is one of the most important part of RAG. Okay, now the vector database compares the query embedding with every stored document embeddings. Here we were having the stored document, this query embeddings are being compared over here, not by just reading words, instead using mathematical similarity. And which similarity? Cosine similarity. I would be writing it here, cosine. Cosine similarity, very important from the point of interview. So, okay, I will tell you now. We use cosine similarity for similarity search. Okay, now we have a query vector. Suppose document A got 98%, document B got 91%, document C got 20%. For example, I gave a user asked a question, it is converted into a embeddings, and this embeddings is being converted with three like it fetches, it compares, and it got three documents with like it is matching 98% with the query embeddings, it is matching 91%, it is matching only 20%. So basically it retrieves top 3 or top 5. Okay, sometime it retrieve top 3 and sometime it retrieve top 5. Okay, like 3 document or 5 document it will retrieve, and more with more similar chunks, more similar to it will retrieve. And if you are thinking that this process takes hours, no, you are absolutely wrong. This process just takes milliseconds. Okay, now we have got our top 5. Oh, sorry. Now relevant chunking we do. What we do? Relevant chunking. Instead of sending the entire PDF to the LLM, we only send the most relevant sections. Okay. Example, suppose your PDF have 500 pages. I will explain you. Suppose. Okay, I can write here also. Suppose your PDFs have 500 pages. Okay. And you ask a question, what is gradient descent? The chatbot retrieves only page number 143, page number 145 and page number 146. These are the relevant chunks. Now benefits of this is it is faster, it is cheaper as I told you in the starting, more accurate, fits with token limit. Okay. After that, we prompt with relevant chunks. Okay. Now we combine the user's question with the relevant chunks. Prompts look like context is gradient descent is an optimization algorithm. User question is explain gradient descent. So the LLM retrieves both document. And without, if we don't have consent, LLM guesses, but if it has consent, LLM answers from the retrieved document. Now, what does generate the final answer? Yes, it is LLM. LLM. So large language model generates the final response. It can be GPT, it can be Gemini, it can be Claude, it can be Llama, it can be Mistral. What I have used in my project, if you see my project, Gemini. Claude we don't use much because of the total token limit, but you have, if you have the premium, you can use Claude, and rest you can use it. They are very good also. Okay, but if you have noticed that the LLM never searches the PDF itself, it simply retrieves the relevant document. Okay, now our step 10 is, I will tell you the step 10, guardrails and post processing. Step 10, So before sending the answer to the user, many systems perform post-processing. Example, it removes step 10, sorry. It removes harmful responses, format, markdown, add citations, check hallucination, apply company rules, and filter sensitive information. So now final output, finally the clean response is sent back to the user. And if you ask me to draw the entire flow recap, so first we have our documents, then we have our embedding models, then we have the embeddings, then we have the vector database, then we have the user question, then we have the query embedding, then we have the similarity search, then we have relevant chunks, then we have prompt, then we have LLM, then we have guardrails, and finally the answer. Okay. So if you ask me a real world example for this, imagine you upload your college notes into a chatbot. When you ask what is back propagation, the chatbot does not search the entire PDF line by line. It converts your question into embedding, finds the most relevant chunks into the vector database, sends only those chunks to the LLM. The LLM generates an accurate answer based on those notes. That is why RAG systems are faster, more accurate, and much likely to hallucinate than the LLM. So now you know the complete RAG pipeline. We have, like I told you, the complete pipeline you can see on screen. So once you understand this workflow, building RAG application with LangChain, FAST, ChromeDB, Gemini or OpenAI becomes much easier because every RAG system follows the same core step. Okay, so this was all. Now I will like make more RAG projects and all that. Many more projects are coming and I'm taking out my time to, now my next target is to make you understand machine learning algorithms, make some new projects on machine learning and about RAG and agentic AI. Is the topic I haven't covered yet, and next I will be targeting simultaneously to teach you DSA. Why DSA? See, you would be have understood, been heard that in AI interview they don't ask DSA. This is complete bullshit. They ask for software engineering role. They ask DSA, and I have a grip on DSA. So I would be teaching. Yeah, it would be in Java language, but I would try to make it optimal for all. And further, I'm also thinking to make a videos on Hindi because many of you commented that you should try to explain on Hindi. So I would be thinking of doing that also. But these are the things of later things. And if you like my channel and you like the what I told you, you can just like my video. You can comment out. I always reply to the comment. I feel very happy when you all comment. Subscribe to my channel, and this was all from my side, and thank you everyone.